Hello students, so here it's Hiral Shah and please welcome back in my YouTube channel. Before starting our today's session, previously we practiced so many examples related to analytic functions, right? And hope you all understood very well now that how to solve analytic functions, how to find analytic functions and to prove analytic functions, which conditions is very much important, right? Either for analytic or for differentiable or for the continuous functions, right? So in this session, I'm going to give one or two examples for you so that you can you do some practice and based on that you can find your mistakes if you don't know. Okay. So that let's start with our today's session with the examples. And I think till the date we did 11 examples based on the analytic functions, and here I have given a 12th example, and the question is test the analyticity of the function w equals to f of z. W yani ki we can say that it's also called f of z, right? So here it's given f of z, and it is given sin z, and as you know, in place of x you have to apply x plus iy, right? So it definitely it will be sine of x plus iy, and w, that is actually your u plus iv. Okay. And here sine of alpha plus beta, it's your angle sine of theta, and in place of theta here it's given x plus iy. So definitely you have to split this angle, you have to split these terms, and after splitting you have to find real and its imaginary parts. Okay, so that's why you have to open its brackets sine of alpha plus beta, and you know the formulas of sine of alpha plus beta, that will be sine alpha into cos beta plus cos alpha into the sine beta. So based on this formula, we are going to write its main equation, and for the angle x plus iy. So here alpha is given x and the beta is given iy. Okay. So sin alpha, so yani ki sin x, cos beta, beta yani ki cos iy plus cos x into the sin iy. And as we did one of the similar example in our previous session, that always you have to convert circular function into the hyperbolic functions, because you don't have the derivation or integration of the circular functions. Okay, so always circular functions you have to convert into the hyperbolic form. So sin x keeping as it is, cos y, and converting this cos iy into the hyperbolic, so it will be cos hy, as I have written here, yani ki this one, and cos x as it is, and sin y iy, again it's a circular of sine function, and sin iy equals to, we can write I into the sin hy, so I cos x into the sin hy. And now this one will be your real parts. 1 minute, I'm just giving highlighting. Okay, so this one will be your real part and this one will be your imaginary part, right? So now u equals to sin x cos hy and v equals to cos x sin hy. And after then this you know very well that you have to apply CR equations. You have to check CR equations whether it is coming is similar or not. And so to prove CR equations you need to find four components: u with respect to xy and as well as v with respect to xy. And this one is in our assignment, and you have to solve with your own self. And if you have any kind of queries, and as you know all that, you can contact me anytime. Now 13th example is given. Show that f of z equals to z into the mod z is not analytic anywhere. Okay, here it's already given that this one is not analytic. It means the CR conditions will not satisfy. ओके, इट मीन्स हम लोग जो फोर कंपोनेंट्स फाइंड कर रहे हैं, ओके, from this CR conditions will not be fulfilled. Okay, so start with the examples. F of z is given, z into the mod z. Now what is mod z and what is z? Z you know very well that is x plus iy, and mod z that we learned in our previous sessions of the, I think in our very first session, mod z equals to under root x squared plus y square, right? So I'm writing here under root x squared plus y square. Now x into the, now just opening the brackets, so this one will be okay, so this one will be x into the this function, and then again iy into the this function. Okay, so just doing the multiplication, you will get x into the under root x squared plus y square plus iy into the under root x squared plus y square. And now you got real and the imaginary part. So based on this, you will find its four components: u with respect to xy as well as v with respect to xy. So again, after this procedure, these examples you have to do in the assignments. Okay, and this one you have to submit it the Google Classroom. And now next one is given 14th example. The question is given, prove that cos hz is an analytic function and hence find its derivative. Okay, now here the function is given cos hz, and this one z equals to, you have to apply x plus iy. Okay, so this one will be cos I z. Now just a minute, in place of hyperbolic I have converted into the circular, because we having a formula of circular, not hyperbolic. Okay, so that's why in the very first step I have converted into the circular form. So now we all having the formula of cos I into the x plus iy. Now in this, first of all multiply I into the bracket, so it will be ix plus I square y, I square plus I square y. Okay, और इधर आएगा I into the x. Now I square equals to -1, right? So this one will be ix minus y, because I square will be -1. And now you have to apply cos of alpha minus beta, यानी कि cos alpha cos beta plus sin alpha sin beta. Okay, so cos alpha alpha यानी कि ix, so cos ix into the cos y प्लस करके, अगर नेगेटिव है तो यहाँ पे आएगा पॉजिटिव साइन, अगर पॉजिटिव है तो यहाँ पे आएगा नेगेटिव साइन, राइट? एंड नाउ साइन एक्स साइन अल्फा साइन बीटा, यानी कि अल्फा यानी कि आई एक्स, सो साइन आई एक्स इंटू दी साइन वाई. ओके, and at the last, as you know all circular functions, you have to convert it into the hyperbolic form. Okay, so it will be cos hx cos y plus I sin hx sin y. Okay, so now you got real as well as imaginary parts. So this is your real part and this is your imaginary parts. Okay, so based on this, you have to check CR conditions is going to satisfied or not, and here I have directly written, it means your CR condition will be definitely fulfilled. Okay, and at the last you have to find its first derivative also, and as you know all, the first derivative of f of z, f dash of z, directly you can write the derivative of cos hz, directly you can write sin hz, but this one you have to prove by using its equation. Okay, so as you know all, f z equals to, I'm writing here guys, z equals to u plus I v. right? So as you know, z equals to u plus iv, you have to find its first derivative, यानी कि f dash of z. Okay, so f dash of z will be the derivative of u with respect to x. So del u upon del x plus I as it is v, यानी कि v upon x, यानी कि del v upon del x. Now we have to write here the components u with respect to x and v with respect to x. So and these both component you have already find into these here equations. Okay, so वो आपको directly इधर ही लिखना है. Okay, now I am converting hyperbolic into the circular functions. So sin h is x equals to, we can write minus I into the sin ix cos y as it is plus I cos hx, यानी कि cos ix we can write into the sin y. And from this we can take a common component I. So into bracket it would be remaining parts sin ix into the cos y. Also I am taking out its negative sign, so it will be here in place of this positive sign, this one will be negative. And already we took out I common, so it will be cos ix into the sin y. Okay, now minus I as it is, and here you can observe the term as C as, यानी कि sin into the cos, cos into the sin. So definitely it will be the function of sin of alpha plus or minus beta, right? Now here it's given a negative sign, so of course it will be of negative alpha, यानी कि sign of alpha minus beta term. And as you know, alpha is given here ix and the beta is given here y form. So minus I keeping as it is, sin of ix minus y. Okay, and in place of this minus y I am writing I square, because we know the value of I square, that is minus 1. Okay, so I am converting into the positive form, so plus into the I square. Now from this these two components you can take out the common one I. So यहाँ पे मैंने I common निकाला है, so into the bracket x plus iy. Okay, and now sin I y, then it will be I into the sin hy. Again repeating guys, sin I y, then we can write its a circular function into the hyperbolic like I into the sin hy. Okay, so here I am converting circular function into the hyperbolic function. So it will be minus, एक I हमारे पास already था, so now it will be minus into the I square. Sin, in place of I you have to write h x plus iy. Okay, and this one you know x plus iy यानी कि z. See guys, यहाँ पे आपको z लाना है, because you can check the question is given cos hz. Okay, और हमें find करना है its first derivative, and you know the first derivative of cos z is, you already know, this is sin hz. Okay, वो आपको पहले से ही पता है, तो आपको पता चलना चाहिए कि यहाँ पे आपको सिर्फ sin hz ही लाना है. So that's why I have converted circular into the hyperbolic. And in place of x plus iy, you have to see, in place of ix minus y, definitely you have to bring the z form. Okay, because as an angle you want here hz. So this one is actually easiest example, but this part is very much important. Okay, and this one is definitely you have to do, and for this purpose I have solved these examples, otherwise I wanted to give it in the assignments. Okay guys, so till now we did so many examples on the method based on analytic functions, and hope guys you all understood very well now that what is analytic functions, how we can find its first derivative. Now in our next sessions we will start one more new method. Okay, So till that, please do the practice of these all the examples, and now we will meet in our next session. Till that, solve the examples, guys. Thank you.